Hello, my name is Amy Upton, and I'm a project architect and the Director of Environmental Design at Grimm & Parker Architects. We had the opportunity to work with Montgomery County government for the last couple of years to design and deliver the White Oak Community Recreation Center. And today I've been asked to talk a little bit about the sustainable features that the county embraced because of LEED requirements, but also piloted for the first time either because of LEED or because of some challenging site constraints, and also just because they wanted to try them out. Here's a zoomed in view of the property, and you can see that the majority of the site is actually either too difficult to access, too remote, or completely encased in forest and steep slopes and highly erodible soils, and also a stream buffer. So we were left with very little site, and what we were left with had a underground fiber optic line running through it as well. So it was challenging to say the least. This is a sort of aerial view showing the amount of forest and the slopes of the site. But what we found was that because of all the challenges, we were forced to sharpen our pencils, look at a lot of trade-offs and holistic design, and what we ended up with was a really compact and environmentally sensitive building that responds to its natural landscape here. The site plan that we ended up with is in the north portion of we retained what was really integral to the core functioning of the building, and by overlapping some of these systems, such as the geothermal well field is actually underneath the pervious paving parking lot, the vegetative roofs were able to offset some of that load for the stormwater management, so we actually didn't need underground stormwater management, and were able to use a lot of multi-dispersion techniques around the perimeter of the site. And as a result, we didn't encroach on the forest. We stayed away from the steep slopes and highly erodible soils. Our LOD, for the most part, remained unchanged. And we even came up with a new solution for the sewer line so that we didn't have to cross the stream where we thought we were going to, and we just connected to it in a very careful way in another location. This building did achieve LEED Gold certification. Our goal was silver as part of the Maryland law, and we tracked silver all the way through, but we always, you always shoot for more credits, and in this case we raised the bar high, and we attempted every single credit we could. And as you can see here, this was in the LEED for new construction version 2.2, the previous version, and we were awarded certification earlier this year with 46 points of gold. Is fairly high gold for us. Here's a view of the LEED scorecard from the USGBC website. It's a little hard to read, but we did go after the majority of the credits. This is a view of the floor plan of the building. As I mentioned, it's a very compact floor plan, and the building has a second story which is stacked on top of the low spaces. You can see that there's 3 large gym areas and a large social hall space. We have game rooms, fitness rooms, a community lounge for seniors, activity classrooms, directors' offices, everything linked by a long corridor with natural daylighting. The second floor of the building here stacks above with art, classrooms, community conference room, and community partnership offices. One of the challenges of the site also is that when we received the site, we could see some previously dumped construction waste in the area that was to be our ball field. We can see it peeking out of the corner of the hill. So it was not really a surprise when the contractor unearthed some contaminated soils in that area. We did a lot of extensive soil remediation for the soil area here, and we started by removing some of the highly contaminated soil, spread out the rest to off-gas. We removed all the contamination such as site batteries, tires, construction waste, and then we added cement to the majority of the rest of the soil to encapsulate the marginally unsuitable soil to prevent leaching out, because as we mentioned, we have tributary to a stream just downhill, very sensitive site on park property. So in addition to rendering all of that inert, we were then also able to save on transportation and fuel costs because we didn't have to haul off very much soil at all to a containment site, and we also didn't have to pay for the cost of containment. I mentioned briefly geothermal. There's a ground source well field, a closed loop system underneath a pervious paving parking lot. There's 80 boreholes that go down 350 deep into the earth, and it's on a 20-foot by 20-foot grid. Those wells have piping with glycol mix that go down in each of them in a closed loop and then come into the building and attach to heat pumps that we have located in every space, and also the energy recovery units on the roof. And in that way, all of our occupied spaces are able to regulate their temperature based on their own thermal comfort. And by using the Earth's natural constant temperature, we're able to reduce our energy usage and the cost of energy, because we're using that constant temperature to go up or go down depending on the heating or cooling season. Then mentioning the pervious paving parking lot, this was a first time for the county was to do this large amount of pervious paving. Originally, because of the site constraints and because of our original stormwater management concept, we were going to have to split our well field into two areas, one here in front of the building and then one behind the building, which is actually at a great physical change, a height difference, and any sort of maintenance of the well field in the future would really be a challenge in that scenario. And so when we looked at the cost of the pervious paving, the benefits that we would get for our stormwater design, in conjunction with the cost and the benefits from the vegetative roofs on the building, we were able to determine pretty early in design that we could offset the need for any underground stormwater structures and just let the paving and the vegetative roof and all of the smaller localized environmentally sensitive devices do the work. And because of that, the whole well field could then be in front of the building, and everything was able to work holistically. Now, these are some construction photos. You can see that the building is almost complete before the pervious paving was poured, and that was because, again, because of the site constraints, there was only really one place that the contractor could stage the construction from and have deliveries, and that was from the front of the building. So because of that, they had to pour the pervious paving at the last moment after the major deliveries were made and the contractor could move the trailer. And because we didn't want to lay down all of the pervious paving and then have it be damaged or filled in by construction activity. So here's another view of the pervious paving getting poured in the upper portion of the site. And here's a close-up view of that pervious paving. It looks more like a Rice Krispie treat. It's concrete, pervious concrete. And then here's a view of some monitoring wells. Montgomery County government decided that since they were going to do this pervious paving for the first time, they would also install monitoring wells in conjunction with University of Maryland, Baltimore County College. And so as a result, we now get data that regularly comes to them, and actually we've been showing that the pervious paving is working really well. It's draining and doing its job through these few seasons. I mentioned that we had ESDs around the site. This building was permitted before Maryland's stormwater management codes came into place, requiring more localized quantity and quality control, but we went ahead and did it anyway with biofilters, grass swales, level spreaders all around the building and the site. And then just to show you some views of this is the planting of one of the two vegetative roofs. There's a large one over the gyms and one over the social hall. It's an extensive system that was planted with a series of seed and plugs, and here's a view of the roof after it got more established. And also, one thing that is unique about the county is, in addition to thinking about maintenance of this, they installed fall protection anchors during construction so that in the future anybody maintaining the roof would be able to clip their harness in to weed or water the roof if it needed to be in time of drought. And also they had an extended maintenance warranty from the installer so that the installer would maintain the roof for 3 years, and now it's been turned over to the Department of Environmental Protection to maintain, but they now also have 3 years worth of stewardship reports, so they can see what was done for the first 3 years and how to continue to maintain this biosystem. The remainder of the site is not irrigated. Actually, none of the site is irrigated. A lot of native drought-resistant plants and landscaping was planted. Inside the building, water use is also reduced via low-flow faucets, low-flow showers, low-flow toilets, 1.28 gallon per flush toilets, and even pint urinals. So we're saving 50% more water than a typical building. And mentioned that we had to do some solar control on the east and west sides of the building. We have translucent roller shades to cut the glare out and vertical fins, but we also have all of this tied to daylight harvesting systems. So we have dimming controls in addition to the occupancy sensors so that we can harvest that natural daylight through those beautiful windows and reduce our need of artificial light. Other management practices that happened during construction included indoor air quality management, and the contractor made sure that all the materials were kept up on pallets, ends of ducts were secured, filters were replaced, and the products all met the low VOC requirements that LEED prescribes. Another unique feature of this design and construction practice for the building was the air barrier treatment. The codes, green codes and IECC codes now require full air barrier systems, but the codes that this building was permitted under did not. We did have a full air barrier system around the building, but Montgomery County went one step further and actually had a third-party inspector or an envelope commissioner observe and report during the installation of everything to make sure that the details that we had worked out during design were being constructed the way that they were intended. And we even had a lot of QC oversight so that when we had bubbles or discoloration of different air barriers, we were able to really point out to the contractor they needed to go back and fix that. Other features of LEED certification, we tracked all of our materials coming into the building, and we had over 20% of the materials were recycled content, a lot of the steel, concrete, drywall. And then we had torn down a couple structures and some parking, so that contributed in demolition, in addition to the new construction, to over 90% of construction waste management being diverted from landfills. So a lot of trash was diverted there. And over 20% of the materials were local. I mean, half of our 500-mile radius is in the water, but we were able to make a good use of the rest of the Atlantic seaboard there and get a lot of our materials, such as siding, insulation, roof membrane, vegetation, masonry, and landscaping, all within 500 miles. And the wood, we have a large gym I mentioned before with a wood floor, and that, in addition to the doors and display cases and blocking, were FSC, so they were sustainably sourced from managed forests and met the FSC requirements of the certified wood credit for LEED. And there were two other initiatives that Montgomery County piloted with this project, and one was a green housekeeping program. Now they have contracts with their cleaning vendors to make sure that everything meets the green housekeeping requirements that LEED EBOM had set forth, and this affects all of their county buildings, and White Oak was a reason why that was started. And green power. We do have a lot of projects moving forward with Montgomery County government now, a couple other rec centers, library, and a health center. And all of these are going to benefit from the purchasing agreement that Montgomery County has with green power vendors so that we can get renewable power sources and recs for the majority of the buildings around the county. So unfortunately I'm not there to answer questions, but feel free to contact me offline or through Montgomery County if you have any other further comments and questions you'd like answered, and my contact information is on the page, and I really thank you for this opportunity to speak to you.